Hi
Hi
everyone, we will
everyone, we will
start at
start at
9
9
pm.
pm.
Okay, so
Okay,
it's
so
time.
it's time.
Hello
Hello
everyone,
everyone,
welcome to
welcome
this
to this
webinar on
webinar on
Chandryaan-3
Chandryaan-3
Futuristic
Futuristic
Photons.
Photons.
First, I
First,
would like
I
to
would
tell
like
you
to
a
tell
bit
you a
about
bit about
Futuristic
Futuristic
Photons.
Photons.
We were
We were
established in
established in
2019 as a
2019 as
global
a global
astronomical
astronomical
society.
society.
We
We
strive to
strive to
promote
promote
astronomy
astronomy
education
education
among all
among
classes
all
of
classes of
society
society
equally.
equally.
We have
We have
conducted various
conducted various
webinars
webinars
under the 8
under
week
the 80
series
week
under
series
science
under Science
communication
Communication
programs. Our
Program. Our
platform has
platform
been
has been
host
host
to 20
to
plus
20 plus
distinguished
distinguished
professors from
professors from
IITs,
IITs,
ISCRs, and
ISCRs, and
such.
such.
We hope we
We
will have
hope
a
we will
great
have a
time
great
today.
time today.
Now,
Now,
our speaker
our
for
speaker
today
for
is
today is
Mr.
Mr.
Ashish.
Ashish.
Mr. Ashish
Mr.
is a
Ashish
core
is a
member
core
of
member of
Futuristic
Futuristic
Photons.
Photons.
He has
He
been
has been
working
working
since
since
8
8
years
years
professionally in
professionally in
astronomy,
astronomy,
covering
covering
different
different
domains
domains
such as
such as
research and
research and
development in
development in
astronomy,
astronomy,
telescope
telescope
manufacturing,
manufacturing,
training AI
training AI
models, and
models, and
etc.
etc.
He has also curated various programs, taught 10K people till date, and has built different observatories. Over to you, Ashish.
Hi guys, hello everyone. I hope I'm loud and clear to all of you.
Yes, Ashish, you're
Futuristic
audible.
Photons, please confirm.
Yes.
Okay, so once again, good evening everyone. What a wonderful evening to be with all of you, and a very warm welcome to this journey to the moon conducted by Futuristic Photons. I'm so glad to have this platform as a launching station to shoot our curiosity and along with some information, some insights for our beautiful celestial neighbor, and that is the moon. So I take this wonderful opportunity to share my insights, share our what are we going to do in the near future, what is Chandryaan-3, and what are its missions, and what are its insights, how different is it from Chandrayaan-2, and first of all, we'll also look at the history of the moon as well, how how it impacted us, how the moon has been moved around us, and so on. So let me just share my screen. I hope my screen is visible to everyone.
Yes, Ashish.
Okay, thank you. So let's begin this journey. Let's begin this journey to the moon, and to do so, let me take all of you back to thousands of years when we humans were struggling to survive on this planet. So you see, currently we have technology, we have luxury life, we have all the equipments with us to fulfill our basic necessities. But sometime in our past, we did not had any of this, and we struggled to fulfill even the basic necessities of life that is very necessary to survive, such as food, shelter, clothes, deciding the time, tracking the seasons. So we were very much, struggling. We were very much not good in that kind of thing. So let's. Uh, I hope you guys are not getting any background sound from my end. Okay. So in this today's session, we will learn about the moon cores, okay, how it formed and how it impacted us, its historical impacts on the evolution of human being. We will look at how the modern astronomy revolutionized, changed the perspective of the way we look at the moon, how other astronomers like Galileo and other, people who looked at the moon and detailed some of its features and how it changed the way we look at the moon. And post that, we'll also see how what are the different missions in the past that shaped this space industry that we say, and yeah, and why are we so interested in the moon and so on. So there are a lot of things to say in this one webinar today. So I hope to people who, yeah, I hope to share that with all of you. So coming back to the moon, yes, it is our nearest celestial neighbor in the sky, right? And it's a natural satellite. And by natural satellite, I mean that it revolves around the Earth, right? And it is nearby, it's in the gravitational field with the Earth. So in starting, as I said, we were struggling with the basic necessities. So the life was pretty tough back then. And to solve our basic problems here on Earth, we took the help from nothing but by learning about the universe itself. Okay, so as we look up in the sky, whether it is a daytime or nighttime, in fact, our about the brightest object in the sky. That is the sun, right? And as we know, the sun is an object that has that has been driven, it has been driving our life from the very starting itself. So now also, when we go to a village, most of the people, they follow their life based on the sunrise and sunset. So as the sun rises, they wake up, and as the sun sets, they shut down their work and go back to sleep. So you see, now also there is this kind of relation, which we are still maintaining between a nature and a human being. So sun, which is like a source of energy, a source of life. So that was the that's an object which guided us with the direction. So as we know nowadays, we have a GPS system, we have compass and all those things. Back then, indeed, there was nothing as such. So when we were traveling to, let's say, far distances for hunting and all, we used to lost our ways, and that's how we figured out that we can use the sun to calculate the time. So it guided us with the direction and the time. Now, what about the night time, right? And so night time, we use stars as well, obviously, to find the direction. But before
Sorry for the
we also
interruption, Ashish. Actually, some people are having some issues with the audio. I think it is echoing or
okay,
they are listening you to photons and earphones if that's possible.
okay, okay,
Yes,
okay.
go ahead.
Just give me. Okay, no problem. Just give me. Okay, I hope it's better now.
Yes, it's
Okay.
better now.
Okay, cool. So, moon being second brightest object in the sky, though which is actually not, since it is closer to us, it looks the brightest. So, moon actually helped us in tracking the number of days. So, right now, we have months, we have days concepts and all. Back then, this concept was not there. So, what did we do? So let's say in today's era, if we talk about the days and all, we say that my exams are coming after 3 months. I have to go to a particular destination after in like 3 weeks or 4 weeks. So now we talk about the days. We talk about in the number of days, in today's era. But back then we used to say that let's meet after 3 full moon nights. So as we know, every month, in every 1 month, we will have one full moon and one new moon, right? So full moon to full moon is roughly equals to your 30 days, or new moon to new moon, you can see it's roughly around to 30 days. So we used to say that, okay, let's meet after 3 full moon nights, or let's meet after 5 new moons. So that's how we, took the moon in our daily lives. So there are even further important findings. There are further even important, insights or learnings that we took from the moon, and yeah, so that we will be covering in next couple of slides. But before that, let's also look at the moon, how it actually formed. So there are different theories that scientists came up with, and the most accepted theory, which we call as, is giant impact hypothesis. Okay, and what is it? It's just it's a theory that says that there was a imaginary planet with of the size of Mars, which collided with the Earth at an angle of roughly around 45 degrees. So as it collided with the Earth, since the Theia was smaller than the Earth, so Theia turned into pieces, and the Earth survived. But as the Theia crashed into pieces, slowly, it just bounded with the Earth's of gravity, and as it was in the influence of Earth's gravity, the pieces got coalesced with each other and formed a bigger rock, you can say. So moon is just nothing but a bigger dead rock. So yeah, so that's how the moon actually formed, and this all happened around 4.5 billion years ago. But obviously, this does not have the moon that we see right now. It's a result of 4.5 billion years experiment of the nature. So initially, when the moon formed, it was pretty hot. Okay, even same goes for the Earth as well. Whether you talk about crust or whether you talk about the cores and all, the surface of the moon was pretty hot. But with the progress of time, the surface got cooled down. Now, after the surface of the moon got cooled down, there were a lot of bombardings. So since right now we see that the solar system is pretty stable, right? There are not many rocks that are very frequently hitting the Earth or very frequently hitting the moon. Yes, there are some impacts that happens every 5 years or 10 years or so, but the impact is not frequent as it used to be back then. So there were a lot of loose rocks back then. So once the moon got cooled down, lot of loose rocks bombarded on the moon, and the lava which was tucked up inside the layers of the moon, it just flew out, it just spewed out of the surface and flowed everywhere. So right now, when you look at the moon, I hope we see these black patches, right? We see the black patches on the moon. So previously, we used to think that just like we have the oceans on Earth, right? There is an ocean on a moon as well. So that is why we call them as a mare or maria or mare, M-A-R-E or M-A-R-I-A. So this is a word. The Maria word is a Latin word, I suppose, a Greek word, which literally means ocean. So because see, nowadays we have telescope, we have tons of knowledge, so we have seen what are these black patches, and we have obviously studied as well. So now we know what composition it is, how it is made up of. But back then, if you talk about around 400 years, 500 years, or even 1,000 years back, this we had no idea about this. So yeah, so that we call those black patches as mare or mare, or literally ocean. There's a black sea on the ocean. And after this bombardment of loose rocks, there was another set of bombardment, which was done by small rocks. Because once the huge rocks bombarded on the moon, now loose rocks are remained in the solar system, and they also started impacting on the moon, and that created the craters that we see in today's phase. So this is how actually the moon formed. But when the moon was when we were actually looking at the moon in the starting days, so it actually fascinated our curiosity. It gave us that spark that okay, sometimes the moon is bright in the sky, it's full in the sky, sometimes it is new moon, sometimes it's half phase. So as the moon changes the phases, what did we do? We tracked it day by day. So there were many, civilizations, including India, Mesopotamia, Egyptian, Chinese. So all these were, too much into tracking the moon cycle. And why? See, we as a humans, we have been struggling for very small things, right? Like your food, your shelter, and we had obviously we did not had the concept of seasons as well. But as we grew up, as we have grown up with the time and we started learning about our night sky, there was another problem that came up at the later stage. And the problem was, see, we humans or any animal you take, we have three basic activities that we do as as a natural form, as a natural organism. One is eat, sleep, and reproduce. So back then, there was no concept of since there was no concept of days, so it was very difficult to track the pregnancy cycle. Okay, so what did they used to do? They made they made this kind of drawings on the rocks. This Egyptian people and other civilizations around the world, they used to track the pregnancy cycle by counting or by counting the number of days or by the counting the number of moon phases. So they tracked the moon cycle, and that's how they understood that okay, we can track the pregnancy cycle with the cycle of moon. And that was kind of one of the achievement, because once you get to know what time is it coming, obviously to your preparation and all. Okay, so that's how we took the fascination. We learned many things from the moon, but obviously as the time passes by, it has increased our curiosity, or it has pulled us in its own gravity. So every time you see our grandmothers and our grandparents, they tell us the story about the moon. So moon is something which have been which have been giving this gist of imagination. So it has entirely opened the new world uh, of our curiosity. But initially, as we know, as we used to think, I mean, we human beings used to think, or especially Catholic people used to think that God has made everything very smooth, without any ups and downs, without any perturbations, without any hills and all those things. So they used to think that okay, Earth may have these all things, but how a God can be imperfect, right? So they thought that okay, the moon is very flat, the moon has no, it's very smooth, right? So now also we say that okay, your face is just like a moon. I mean, it's a kind of compliment that we say, but when you actually look at the moon through a telescope or in a deep way, then you find out that moon also has its own rugged features. It has rugged terrain, and that was first being shown up by the this guy Galileo. But let me remind you that the Galileo is not the one which you most of the, which we most of the people think. So so we think that okay, Galileo is the one who actually invented the telescope. But to omit this myth, let me state that Galileo is not the one who actually invented the telescope. So I hope now, by now we might be thinking, okay, then who is the inventor? Because Galileo is so famous, and since he has not actually invented the telescope, then who was the person behind it? So the person behind the invention of the telescope is a Dutch optician named Hans Lippershey, or Johannes Lippershey. So generally, we don't give him an official credit, kind of reward to him. But yes, he was the first person to file the patent. So that's how we generally say that okay, Hans Lippershey is the one to invent the telescope, because back then the telescope was a very simple device, right? Just put two lenses at the end of at the end of the tube, and there you go, the telescope is done. So, and that's a very simple task, right? I think anyone could do, if if they have the if they have the hollow pipe. So this was actually done by the Hans Lippershey, and after I think 3 years, when the Galileo was a professor in a university, he he took the telescope and then he pointed at the moon, and what he noticed that there are moon have different features, like it has mountains, it has craters, it has rays. So a lot of rugged terrain, or a lot of ups and downs, a lot of perturbations are there, and that actually challenged the belief of the people. So yeah, for that he was house arrested and all those things happened. But yeah, so this is the guy who actually revolutionized the modern astronomy, and that's how we say that the Galileo is the father of modern astronomy. Now after, and this was, yeah, by the way, the Galileo, I think it was around 16 or 10 1611. So I think that is around 400 years back. After 400 years, if you say, or 350 years, again we humans got very much interested in on the in the moon. So since as during 1960s, when Soviet Union, USSR, and USA was actually into a kind of a tug war, who will be the first to go to the moon, or who will be the one who to to triumph this the region of space. So yeah, obviously Russian also very they were very much into advanced technology. They were the one who sent the first people to the moon. They were the one to send the first male person to the moon. They were the one to send first female onto the space. Sorry. So and also they were the one to send the very first satellite. But, and I think that was a lunar orbiter one. But there is a glitch that happened with the lunar orbiter one. Due to some reason, that lunar orbiter one, it did not get into the lunar orbit, and did not go around the moon, did not make it. It was unable to make to the moon. So it was a kind of failed mission. But yes, that was the very first mission that we tried to escape the Earth's gravity and get into some other's gravitational field. But post that, just I think couple of years after this lunar orbiter one, USA launched its orbiter Luna. So they launched this orbiter, and that made its journey successfully to the moon. And the image that you see on the top left is nothing but this is our first satellite. Okay, this is our first image of the Earth and Moon taken by the first satellite of the US. So you know as we are living here on Earth, it's very difficult. We cannot see our home, we cannot see our Earth itself, right? So when the Apollo people went to the moon, they said this is the first time we have discovered our Earth itself, because that's the first time they have actually seen the Earth. And as this image shows, this is the first image when we were actually able to see the Earth from the space. So yeah, going ahead, we different agencies have been trying to uh, send this different rovers, different landers onto the moon. So up till date, three countries have been able to perform. So one is your USA, NASA, and another is of course Russia, and third one is none other than China. Okay, so yeah, so there were a lot of we had lot of learning outcomes from each of these space agencies. So some brought the sample back to the Earth. So this lander Chang'e, which was from the China side, they landed this Chang'e on the far side of the moon, and they brought the sample back to the Earth for study purpose, right? And obviously, we know there were 6 Apollo missions that were carried by the NASA, that made the history itself, right? And each of these Apollo missions had their own significant contribution to the science. So some kept laser, some kept a mirror on the moon, so that when we reflect, when we shoot our laser here from here to the moon, and at its come back, we can calculate the distance. We had the sample being brought back by these Apollo astronauts. So a lot of learning has been done by these Apollo missions, and obviously other spacecrafts as well. So there is another spacecraft, that is the LRO, Lunar Renaissance Orbiter, that has been orbiting the moon, and it is probably the one of the best orbiter we had till date, and who have been capturing the moon in a very high resolution images and sending back to Earth. So we have this like great data to work upon. So if somebody wants to do so. So yeah, so this kind of thing we have been doing since decades, and it's been 50 years we did not go to the moon, and now I think this Elon Musk people and other people, even as NASA, by the help of mission Artemis 1, now we are trying to reach the moon once again. So yeah, so till date, if I say, only 12 astronauts have ever landed on the moon out of this 7.5 billion people that we have here on Earth. So this actually obviously made the history, and post that we have sent a couple of missions to the moon. But if you talk about India's journey, so India is the 4th country that has been trying to land on the moon, that has been trying to understand its surface, understand its geological features, and so on. So only 3 countries that have made their way successful to the moon. So India is going to be the 4th one. Now, yeah. So now, if you talk about, okay, has been there any else deep space missions from the India itself? So I would say no. So this Chandrayaan series, which started from Chandrayaan-1 back in 2008, I guess, yes, back in 2008, that was our first mission. That was our first deep space mission. Okay, and because why we call it as a deep space mission, because that was the first time when we escaped out of Earth's gravity and inserted our spacecraft into some other gravitational pull. So in 2010, we made our successful way have made very significant discoveries. Okay, so previously we used to think that, okay, only Earth is the one that have these oceans and water and all, and as we thought those black patches as the sea, though which they are not, but that literally came out true by the help of Chandrayaan-1. So Chandrayaan-1, it was an orbiter. It did not had any lander, it did not had any rover and all. It was just an orbiter. Okay, that orbiter, that mission gave us a very wonderful insight, a very wonderful learning, or you can say discovery from the moon, and that was the discovery of the water particles in the soil of the lunar surface. So now you may think, okay, where does this water come from on the moon? Or actually, is there water on the moon? Right, so this is, so if you ask anyone, if you ask any a kid or anyone, do you think there's a water on the moon, they might obviously say that of course no, there is no water on the moon. But this spacecraft made this word literally true, that there is water on the moon, but obviously not in the form of liquid state, because there is no enough atmosphere, there is no atmosphere itself, right? There is no specific conditions to have the water in a liquid state. But in the south region of the moon, there are some craters. Okay, there are some craters where the sunlight has not been there, or sunlight has not made its way for billions of years, just because it is, the rim is hiding from the sun's rays. So that area, they since that area did not experience sunlight for billions of years, so whatever impact, whatever the water have made its way to the moon, maybe by the impact, by the way the Theia created the moon or so, somehow the water has made its way to the moon, and now it's still existing in those lunar soil, which is hiding from the sunlight. So this lunar probe, or this spacecraft Chandrayaan-1 had a probe called impact probe, I think. Yeah, lunar impact probe. And what do you mean? What do I mean by lunar impact probe? It's impact probe, right? It's a probe that is actually going to impact. So we intentionally impacted, or intentionally threw this probe onto the moon, so that it will splash the surrounding. It will splash the soil, and then that was being detected by the orbiter itself. So as you see here, this the spreaded out, this blue thing is nothing but the soil which was spreaded out by this impactor probe. So yes, Chandrayaan-1 was a successful launch. It was a wonderful mission from the ISRO, and that's all that we made our own way. That was the first time that we actually get to the moon, orbited around, did wonderful observations, and send us very detailed images. Now, 4 years back, in 2019, during this time only, I think it was July, when we again tried to send Chandrayaan, next mission of this Chandrayaan series, and that was a Chandrayaan-2. But somehow Chandrayaan-2 did not made its way, right? We all know that, and that was a pretty kind of sad moment. But I would not say it was a failed mission. I would call it as a partial successful mission, because there were three basically module. Okay, there were three module on the Chandrayaan-2. One was your orbiter, which was supposed to orbit the moon, and one was your lander, Vikram lander, which was named by none other than Vikram Sarabhai, the founder of ISRO. So that was supposed to land on the moon, and inside this lander module, inside this lander housing, we had the Pragyan rover. But there are some problems, there are some challenges that the science has to face when we're trying to step on the moon. So the challenges are, the very first challenge that I see, that there is no atmosphere, right? So if you talk about landing on a planet such as the Mars, so Mars has a little bit of atmosphere. It's very thin though, but it has a little bit of atmosphere, and that can be used to or that allows us to use a parachute kind of thing, right? Because parachute is something that can be used pretty easily to land to land something. So like here on Earth, we use parachute, just to when we do skydiving and all. So similarly, we have used the same technology even when we were trying to land on Mars as well. But since the moon is devoid of any such atmosphere or any air, basically, so yeah, it's very it's very difficult. So the usage of parachute did not, it don't even come into the picture. So what do we do then? How do we land on the moon? We use thrusters. Thrusters, they are the way to control the maneuver, to control the speed and all those things. So with the Chandrayaan-2, what happened? They were attempting a controlled landing near the lunar south pole. So, that is a region that, we believe that is a water ice. And that was also discovered by the Chandrayaan-1 as well. So, there is something called 10 minutes of terror. So why do we call it the 10 minute of terror? That is nothing but that is a very crucial time when the lander is actually trying to descend, or it's actually trying to decelerate, means reducing its speed. Yeah. So initially, as as the lander was trying to land, the speed was somewhere around, I think, 1.2 kilometer per second, and that's a very huge speed actually. 1.6 or 1.7 kilometer per second. That means if you just blink your eye, the lander has to travel 1.6 kilometer, and that's a pretty huge speed, right? With that speed, obviously the the material which the stand is made up of, they will not withstand with the pressure, so they will break off, and that means the lander will crash. It's a hard landing, right? So now yeah, so what happened in those 10 minutes? So people used to, there were a lot of study that have happened, and ISRO also did not officially released what actually happened with the Chandrayaan-2, what were the what were the reason for for this failure. But but the scientists from ISRO, they say that during this 10 minutes of terror, what actually happened, the lander was supposed to decrease its speed from 1.6 kilometer per second to 140 meter per second, just 140 meter per second. That's a very that's a huge amount of deceleration. But unfortunately, it did not happen. The communication with the lander was lost during its critical phase as it approached the moon surface. And it was just happened when it was just, I think, some few kilometers, I think it was within a single digit, like let's say like a 4 to 5 kilometer from the moon surface. So obviously, yeah, that was a very much saddening for all of us. But now we are again back with the next generation of this series, and that is Chandrayaan 3, right? So now you might think, I have seen the Chandrayaan-3 images, or I have seen the Chandrayaan-3 photos also, maybe on a Google, or maybe on somewhere. So you might think, oh, this Chandrayaan-3, the design seems something similar to the Chandrayaan-2. So yes, the design is a little bit, it's kind of same. It's also it's also going to be launched. It's also going to be land at the kind of similar site nearby to it, and but yeah, it differs from the Chandrayaan-2 mainly in two ways. Okay, so firstly, it will not have any orbiter, just like its predecessor. So, and secondly, there is a very wonderful instrument that this Chandrayaan-3 has, which we will discuss in the next slide. But first of all, congratulations to ISRO, and hope for the best that we make our way successfully this time, and that is nothing but the tomorrow itself. So tomorrow, it's the 14th July, and the ISRO is going. Oh, sorry, not tomorrow. It's day after tomorrow. Yeah, it is at 12. So 14th July, ISRO is going to launch the Chandrayaan-3 at around 2:45ish p.m. So I suppose this again the second time when we humans will watch the Chandrayaan-3 launch together at all once. So you see, this is a subject which brings the entire humanity together, which bounds us, which force, I would not say force us, but it mm, yeah, I mean, it allows us to imagine the same thing, and being millions of people at the same time, with the same kind of imagination. So yeah, so this time, yes, so this time the Chandrayaan-3 is going to be launched, and I hope so it happens successfully. Now, yeah. Okay, so yeah, before I go to the next slide, you can see on the left side there is a tentative Chandrayaan-3 landing site, and you can also see the Vikram's lander's crash. The site where the Vikram lander was crashed up. So yeah, it's pretty close to that, but hopefully it makes our way. So let's see, hope for the best. Now coming back to its payload. So as I said, Chandrayaan-3 is not going to have any orbiter. Okay, it will not have any orbiter. It will have only and only lander module, right? So lander module will be attached to a propulsion module. So propulsion module is nothing but a guidance module, basically, that will guide the lander itself. But yes, Chandrayaan-3, it differs in a couple of ways, as one being devoid of any orbiter. Secondly, it has a one kind of, it's a payload. Yeah, so there is a second payload which we call it as a shape. Okay, and the abbreviation of shape is spectropolarimetry of habitable planet Earth. So you might think that, oh my god, the name is pretty it's pretty tough to say. So, but it's very simple. So yeah, I would like to, yeah, boil it down for you people. So see, basically, we humans have been searching for, as we know, we humans have been searching for life, right? We have been searching for life on other planets, and most of the time we, look for we look for these kind of signs, like whether the planet has oxygen or not, whether the planet has water or not, or whether the planet has nitrogen and other, building blocks of life, and other elements, so on. So why not we look at our why not we look back at our earth itself and see how what kind of sign the earth is giving, right? And that same kind of sign I can look in other planets as well. So then I will have much more precision, or I will have much more data to look for, on other planets or on other nearby stars. So what did we do? What do? We send a payload, or we send an instrument on the moon that will look back at Earth and understand how the light is being reflected by Earth. Okay, and that can be useful for the scientists, to search for the other planets that exhibit similar kind of life signature. So yeah, so this time, ISRO scientists and engineers, they have also modified both the software and how hardware components as well. So initially we were supposed to land on the moon with the speed of around 2 meter per second, but now we have increased the speed. Now we have given some kind of buffer, like now the lander may be able to land with the speed of 3 meter per second also. It's a little higher speed, but the land of or the leg of these lander has been modified. Now I think they have used some different kind of material over here to withstand with the more pressure. So yes, that's a one difference. They will be now the lander will be able to land even with a higher speed. That's a 3 meter per second. And also they have specifically focused on the thrusters as well, after learning the challenges that the Chandrayaan-2 had faced. So yeah, so the team, they have devised different sequences for soft landing, and they have made some improvements to the lander. And there is one more thing which is different from the Chandrayaan-2, and that is, in this lander they have used 4 thrusters, okay, instead of 5. And obviously stronger legs, extended solar panels. So this time we are using bigger solar panels, and also we have increased the fuel capacity, so that we have also increased the number of the life. We have increased the life of this mission. So right now we have planned to we have planned that lander will sorry so yeah, the lander will survive on the moon for 14 days, and that is about 1 lunar day. So yeah, so the lander will survive for 14 earth days. And this, now you may ask, like, okay, where is it going to be launched? So yes, as I showed you in my previous slide, it's going to be launched at close to the going to launch close to the site where the Vikram lander crashed. And if you talk about the coordinates and all, that's 70 degrees south, okay, and 30 degrees east, I suppose. Yes, it's east. So yeah, this time we have, as I said, we have also added much more fuel to to manage more disruptions, and provided the capability to recover if required. So yeah, this is the this is which Chandrayaan-3 is going to follow. So we don't directly shoot the spacecraft onto the moon, right? Because that will take a huge amount of fuel. And why it will take a huge amount of fuel? Because the spacecraft have to leave the Earth's gravitational pull, right? And to leave that gravitational pull, we require the velocity of 11.2 kilometer per second, which is nothing but the escape velocity itself, right? But if we want to shoot our rocket with that velocity, that may require a huge amount of fuel, which is not kind of you know which is not good, because it will anyways increase the its price or its cost. So it's not economically effective. So what do we do then? We again take the help of the Earth's gravitational field itself. So we launch it with some speed around 8 to 9 kilometer per second, and then we move around the Earth. We give a jig around the Earth, and again we burn the thrusters, or again we turn on the engine, and again shoot it even to higher, even to a higher altitude. And then once it again, it once again complete the Earth's orbit, and as it completes the orbit, we again burn the engine, and it again achieve the higher orbit. So it is just like, when we fly a kite. When we fly a kite, and as the air passes by, what do? We lose we lose the thread, and then again we try to pull it back, and again we lose the thread, and again we try to pull it back. So it is kind of, we are giving the speed to the spacecraft by using the Earth's gravity itself. Okay, instead of just by pouring and just by using a huge amount of fuel. So yeah, it will make around, I think it will make 5 to 6 Earth's orbit, and post that it will be transferring to the lunar trajectory. So yeah, it will enter into the lunar orbit, and again it will descend. Again it will increase the distance. Again we have to turn on our engine, turn on our thrusters, and get closer to the moon. And orbit by orbit, we will achieve under 100 kilometer by 100 kilometer orbit. And yeah, hope to have a safe landing this time. So once the lander is, once the lander enters the moon, once the lander enters the moon, it has to turn on its thrusters, right, to have the soft landing. And what do I mean by soft landing? That means a gradual reduction in its speed or in its acceleration. So it has to be very gradual. We cannot decrease it all of a sudden. It has to be gradual. And once the rover lands, once the lander lands on the surface, the housing door will open up for the rover to move around the moon and do its experiment. Okay, so there are different instruments that that ISRO has involved in. ISRO has attached this to this lander and the rover, which is Ramba. So Ramba is one instrument. There is one another one that is a ILSA, that is to sense any seismic activity. There is a shape which we discussed to sense, or to look for the life that to look for the signals, the light signal that Earth is giving back to us, giving back to the moon. There is another X-ray spectrometer. Okay, to yeah. Now the power. Now you might think, okay, these many instruments might use a lot of power, right? But the power which the propulsion module is going to use, that is as equal to the power that our iron use. The iron that we have our home, it's around, I think, 750 to 780 watts or 800 watts. So that's that much power this propulsion module is going to use, and the lander is going to use even lesser power. Okay, so yeah, that's the thing. So this time we have improved the accuracy of measurements, and we have also included a new sensor on the lander that is called the laser Doppler velocity meter. So this sensor will help us to study the lunar surface by using the laser technology to measure different components of the velocity, like in which direction it is going and how much velocity it is. So by adding this sensor to the existing instruments, it improves the accuracy basically. So yeah, this time the Chandrayaan-3 lander is also equipped with the any hazard, any lander hazard detection, okay, and avoidance cameras. So that will help, that will be in the coordination with the orbiter and the control mission during the landing process. So for this mission, there will be 2 cameras instead of one on board, and these cameras will play a crucial role in identifying if there is any hazard is going to happen, or avoiding them for a safer descent to the lunar surface. So hopefully we make our way this time to the moon. So there is a small animation that shows how the Chandrayaan-3 is will be revolving around the Earth, and will make its way to the moon. So you see, this violet line is nothing but the trajectories of the spacecraft around the Earth, and give it give it a gravitational slingshot and throw it at such a point of time where as it reaches the moon orbit, the moon also will be there. So yeah, so this way we can, this is the way which we have used for the Mangalyaan as well. So yeah, this is a pretty nice, hopefully, I'm hoping, I have a lot of hope actually this time, that, and I think along with me you guys also, will must be really excited to have the India's first spacecraft onto the moon for the very first time. And with this success, or with this mission, we are going to be the fourth country to do so. So cheers to ISRO, and hope for the best that we do this successfully. So I hope you guys have had some insights on Chandrayaan-3 and the moon, and yeah, I can welcome all your questions if you have.
Hello, sir.
Yes, yes, ma'am.
Amoli here from Jaipur. Sir, it
Hello, ma'am.
was really, really very good to hear about Chandrayaan. Although we knew some things, but yes, the way you explained the things were really, really intuitive, and we really
Thank you so much,
enjoyed
ma'am.
your session. Thank you
Thank you
so
so
much,
much, ma'am.
sir,
Thank you so much, ma'am.
and all the best to Chandrayaan.
Yes, yes, yes. Hopefully, we make this time, and that is going to be, that will make the history itself actually.
Definitely, and ISRO is known to make histories.
Yeah, absolutely, absolutely, ma'am, absolutely. Thank you
Thank you,
so
sir.
much. Yes, ma'am.
Sir, may I know is there any particular reason that why we are not sending orbiter this time?
Okay, so basically, our main mission is to actually land on the moon, right? And we already have a lander up there, that's from Chandrayaan-2. So that is why we did not feel that we did not feel the presence of an extra orbiter. So since the main mission is to land on the moon and not just to orbit, not to orbit the moon.
So why we used last time, sir, an orbiter?
We used just to it was used to synchronize, or to basically like kind of an eye on the lander, so that as the lander will descend to the moon, it will capture some images and will send back to the orbiter, and orbiter will send back to the earth, to the ground station, and this way the communication will be maintained. So so you can say the orbiter one was a kind of mediator, a kind of a module to make sure that the lander is going to land safely.
I sir. Thank you, sir. One more last question, sir. That what is the
Mhm.
total time duration of this Chandrayaan mission, sir, till the sample material will reach at Earth?
Okay, so basically, I think it will take around 12th August. So by 12th or 13th August, it is going to make it is going to land on the land on the moon.
Thank you, sir. Thank you very much.
Actually, there are some questions in the chat too.
Okay.
First
Oh,
of
no, no
all,
problem.
yeah,
I'll just look at it. Yes, yes, sure. Okay, why we are unable to see the second phase of the moon? Okay. There is a one wonderful example that I use every time. So we play this game, where two people join their hands and they revolve, right? That a game which we have been playing since our childhood. So when we play that game, you see we are moving around a particular point, right? And for both of us, for the both participant, none of us will be, none of each participant will be, able to see their back. So if you talk about, so similar thing goes for the Earth and Moon as well. So it is a kind of Earth and Moon. They are, joining their hands and they're revolving around a common point. So this kind of locking is called as a tidal locking. Okay, so that's the reason we are unable to see the backside of the moon. And also, if you go technically, the rotation rate of the moon is more or less similar to the revolution rate of the moon. So by the time it moves around the Earth with the same speed, it turns also around. So it is just like it is never showing its back to you. So that's the reason we don't get to see the backside of the moon. I hope I answered your question. Okay, what is Luna 5? Okay, so Luna 5, is also a planned, lander mission from the Russia, and they are planning to land this lander. No, so the launch date is somewhere around in August, if I remember. So this is another lander, which will be from the Russia side, and the launch date is around in first week of August or so in this year, 2023. That's another upcoming mission. Okay, what's the full form of EBN in Earth's trajectory orbit? This I'm not sure of. If any one of you have this full form, then you could share, please. Okay. Yeah, thank you so much. I loved to be in this platform, and it was wonderful to have you guys on platform and share.
Thank you, Ashish, for hosting this wonderful webinar. I'm sure everyone loved it. We hope to see you soon hosting more webinars for next week. And thank you everyone for staying with us until now.
Just one more question. Just one more. I think the Prerna Madan, she or he has posted this question. What will be the benefit for landing speed to change from 2 meter per second to 3 meter per second? See, if you're trying to land at a lower speed, right? If you're trying to land at a speed of 2 meter per second, then you need to have a very precise thrusters, right? And also you need to have your if you have strong legs, you can land with a much higher speed as well, right? Because then your legs will be able to withstand with that kind of pressure. So this time the legs of a lander are much more sturdy, much more harder, much more they can much more kind of strong to withstand with much pressure, so that they can land even with the higher speed as well. So previously, in Chandrayaan-2, it was supposed to land with the 2 meter per second, but now since we have our legs made stronger, so we can land with the more speed as well. So this time we can also land with 3 meter per second. Okay, how can the Chandrayaan-3 help in its research of exoplanets? See, so basically, when we look at the exoplanet, right, we look for the signs of elements that made the life itself, right? So as our human bodies, most of the human body is made up of water, right? And water is nothing but hydrogen and oxygen. So hydrogen, as we know, it's the most abundant element in the universe. So that's pretty much common to find. Next element that we try to look for is oxygen, right? Which is obviously important. to breathe, and for the survival. Next important thing that we look for is the carbon. So as we know, our body or any living body is made up of DNA, and DNA is nothing but made up of nucleotides or amino acids, and amino acids are further nothing but made up of proteins, and proteins are further made up of your I think it's vice versa. So they are made up of nothing but the carbon, nitrogen, and oxygen. So we look for these elements actually, but we are still struggling with this kind of with this domain. So what do we do now? We go back to the moon and we see how the Earth signature is, how Earth is giving the signature of the life. So by taking that signature, by taking that spectrum as a reference, we use that data to search the other exoplanets. So that way we will be much more precise to to find the exoplanets. We can see only 59% of the moon. Yes, we can see only 59% of the moon. That's called lunar liberation. That's for the another day, I suppose. What's the role of AI in this? Yes, so it's basically there are a lot of data analysis that is going to happen, and there are website as well from which you can download the data and do your own analysis. How will be the rover charge itself? So any spacecraft that we send to the space, be it your orbiter, be it a probe, be it a lander, rover, whatever it is, most of them will have different kind of power systems. Okay, and the very common power system that we see is nothing but the solar panel itself, right? Because they are the cheapest way to get the energy from the sun. But if we are sending anything that is very far from the sun, let's say to the Uranus and to the Neptune and to the further further in the solar system, we use more advanced form of or use different kind of power mechanism. So one of them is the thermonuclear reactors. So that also can be used to gain the energy. But for the Chandrayaan-3, we the solar panel will be providing that energy. And yeah, so I hope everyone have enjoyed, and it was lovely to be the part of the discussion. Hope to see the success in coming 2 days, and make sure to tune your TV to look for the history to to establish. Thank you so much, and have a nice day. And thank you so much, guys. Yeah, I think there is another question that has popped. Okay, can you please explain the process of rocket orbiting around the Earth by its gravitational force to the moon gravity? Okay. See, Aman, Asmit, sorry, my bad. Yeah. So there is a one thing called escape velocity. Okay. Now, what do I mean by escape velocity? See, as we jump on the Earth, we don't directly shoot back. We don't directly shoot ourselves to the space, right? We come back to the Earth, land back to the Earth. When we shoot the football, can we shoot the football straight to the space? No, right? That would require huge amount of speed. So the speed which can throw you outside of the Earth and leave its gravitational pull, that speed is nothing but the escape velocity. So yeah, so anything that you want to send outside the Earth and leave its gravitational pull, you have to have the velocity of 11.2 kilometers per second. But stating that, or if we give that kind of velocity, that would require a huge amount of fuel, right? So this is not a good trade-off, I would say, or you can say this is not cost effective, because as you increase the amount of the fuel, you have to increase the housing or the tank of the rocket itself, right, and the size of the payload as well. So again, it is not a good idea. So what do we do then? So cleverly, what do? We shoot the spacecraft into space, just right above the Earth, a few kilometers. Okay, and then we we make the spacecraft go around the Earth, and as it goes around the Earth without any thrusters turned on. So what will happen as it is going around the Earth? At some point of time, when it is in the orbit, we turn on the thrusters, and what thrusters do? They shoot the spacecraft straight to the tangent of its orbit. Right. So as it goes into a higher altitude, again, since it is still under the gravitational pull of the Earth, again it will make its way back to the Earth and revolve around it. So again, as it completes the orbit, again we turn on the thrusters, and again it will attain higher speed. So that way, yeah. So that way we will make a couple of rounds around the Earth, and there will be a time when we will be ready to launch the satellite into the lunar orbit. So that time we will just turn on the final burning will happen, and it will shoot itself to the lunar orbit. And as it shoot to the lunar orbit, it will come under the moon's gravitational field. So then we don't need to worry about the spacecraft will go here and there, because we are shooting the spacecraft into the moon gravitational field itself. So once it goes to the moon's gravitational field, it will start making orbit around the moon itself. But since the altitude will be high, so what do we do? Again we turn on our engine, again we put the thrusters, and again it will descend down. Again it will, this time it will reduce the altitude. So as it reduces its altitude, it makes its way closer to the moon. So by burning the thrusters in multiple times, it will decrease its altitude, make its way to the moon, and dang on. That's how it will land on the moon. I hope that was clear. Okay, guys. See you. Hope to see you in the future, and thank you so much. Thank you so much. Stay in touch with the Futuristic Photons. You guys are such an amazing community, who have been bringing back such innovative, and such informative webinar. So thank you so much, Kirti. Thank you so much, Tane, and the entire team for making this webinar successful.
Thank you so much,
And guys,
Ashish.
please fill the feedback form too. It really helps us get an idea of what you guys like and don't.
Bye, guys. Have a good day.